Oh my God. That's what we think. We're looking at, I got a question about this problem here, number 4. Are you talking about which one of these? These are the two where you have to graph stuff, right? So which one are you talking about? Private chatter. Which one are you talking about? Oh, the midterm. I'm sorry. I'm looking at the practice final. Oh, geez. You're talking about midterm corrections you're working on, maybe? Is that what you're talking about? Or practice midterm? All right, now I'm really confused. Working on corrections. Okay. So midterm number 4. Oh, shit. I hit the wrong button. Hold on. All right, come on. We can do this. Oh, yeah, definitely do not want to see X, Y. So, all right. So somebody's asked me a question about this problem. I mean, this is not the same problem everybody had on the midterm. I want you to list the transforms and then graph by first graph of the base function. I don't say a word about making a table. I don't want to see a table. In fact, I think I was very explicit that I definitely do not want to see a table. I want that graphed using transformations. Shift left, right, up, down, stretch, reflect, all that kind of stuff. Yeah, understood? Okay. Now, I had another question which made complete sense because it relates to something that I would do, that I said I would do. So in the practice final, the very last thing I put was just sort of a cryptic plotting parametric curves. So we sort of looked at a parametric example. Please let parametric not be that horrible. It's just plugging values in and getting values out and then plotting the points you make. It's nothing crazy. And all right. So I promised I would do a polar curve example. So I'm going to go to our polar graph paper. We're going to do a polar curve example. And I got kind of a nifty one. Nifty example. Let's see. I think, all right, I'll do this for you guys because I know now I'll be honest, I have trouble remembering the polar symmetry stuff. I just can't keep it in my head for some reason. I can kind of piece it together if I need to. So I'm not going to make you memorize the polar symmetry stuff. But if I give you a problem like this, where I say graph this, right? If I give you a problem like this, I might tell you what symmetry has, or I might, tell you what the test is and have you do it so you verify it has a certain kind of symmetry before you start graphing it. But this actually has x-axis symmetry, so polar axis, which is also called the x-axis, the polar axis symmetry. Now, why is that good to know? If I know it's symmetric with respect to the x-axis, what angles do I need to plot before I can just start copying what I've done? Does that make any sense? If it's symmetric with respect to the polar axis, also known as the x-axis. I didn't hear you, but I saw you say it. 0 to pi. I'm not sure why your mic's not working. All right. I don't know if that makes sense there. All I have to do is graph from 0. Sorry, go ahead.
That is what I said.
Yes, good. All you have to go is go from 0 to pi in a table, because then I can just copy what I did below because I know it's symmetric to the x-axis, also known as the polar axis. Are you guys with me so far? I'll take that as a yes. Okay. So then I make my little table. I don't know. Let me do it the traditional way. I always do this backwards, but we'll do it this way. So help me out. So if I put an angle of 0 in, what do I get out? Anybody? If I put a 0 in, what do I get out? What's cosine of 0? Are you guys really out there? I know Austin is. I can see him. That's all right. Somebody's apologizing for being late, but I don't believe there's people behind the names out there. Somebody has to know what cosine of 0 is. Okay, cosine of 0 is 1. I love it. So then when you multiply it by 6, you get 6. Okay. All right. What if I put pi over 6 in there? Well, that is pi over 6 something good to put in there? Can you guys see? You sure? Do you know what the cosine of pi over 12 is? You do? Neat. Tell me. What's the cosine of pi over 12? Do you understand if I put pi over 6 in, won't it be 1/2 of pi over 6 is pi over 12? Do we know the cosine of pi over 12? No. Do I want to put pi over 4 in there? If I put pi over 4 in there, I get pi over 8. Do we know the cosine of pi over 8? No. So the next thing I want to put in there is pi over 3. Unless I want to just start shoving stuff in the calculator. I'm not going to do that yet. Yeah, since the first thing I do is cut things in half, I have to put larger angles in. Well said. So what I get when I put it, what's cosine of pi over 3? I'm sorry, cosine of pi over 6, because I'm putting a pi over 3 and I get pi over 6. Cosine of pi over, is everybody with me? I just put a pi over 3 in. Half of pi over 3 is pi over 6. What's cosine of pi over 6? Root 3 over 2, I like it. And then times 6 will be 3 rad 3, which is also known as, I have no idea, 5.2. What is 3 times rad 3? Holy shit, 5.2. Neato. Are you guys with me so far? Nothing amazing's really happened yet. Again, does everybody understand why I skipped pi over 6 and pi over 4? Because I end up with shit I don't know. Now, you could just plug it in your calculator. You could, but I'm not going to do that unless I need to. All right. So let's see what we got so far. So if I just use the natural scale, 1, 2, 3, 4, 5, 6, there's that. And then a pi over 3, it goes to 5.2. So let's see, 1, 2, 3, 4, 5.2. Okay. And then let's see, what about pi over 2? If I put pi over 2 in, I'll get cosine of pi over 4, which is rad 2 over 2. Times 6 is 3 rad 2, which is 4.2. You guys can, is it, Jeff? Do you agree that? Yes, I do. Okay. You can double check me if you want to. All right, so I mean, all right. So then at pi over 2, it's 4.2. So 1, 2, 3, 4.2, a little bit up in there. Okay, so it looks like it's going around. All right, just bear with me. Let's go a little bit further. So do I want to put 2 pi over 3? That becomes pi over 3. I can do that. 2 pi over 3. Half of that is pi over 3. Cosine of pi over 3 is 1/2 of 6 is 3. Sweet, a nice whole number. Kick ass. So a 2 pi over 3, I'll go out to 3. All right, this thing is curving around like a normal thing. It doesn't look like I need any intermediate values at the moment. Looks okay. So let's see, can I put 3 pi over 4 in there? If I do that, half of 3 pi over 4 is 3 pi over 8. I don't know anything about freaking over 8 shit, right? So I'm not going to use it. So let's use 5 pi over 6. That becomes 5 pi over 12. Oh shit, can't use that one. 11 pi over 12. No, there's no way in hell. So pi, if I put a pi in there, cosine of pi over 2 is 0, right? So now this comes back to 0. So it looks like it's doing this kind of thing. All right. And again, you could do more points and plug them in the calculator, right? And then I would just keep going. Let's kind of pick this up over here. Where am I at? 7 pi over 6 would become 7 pi over 12. 5 pi over 4 would become 5 pi over 8. 4 pi over 3 would become 2 pi over 3. I could do that. Does everybody see what I'm doing? Pick something. I cut it in half. This is something I know. So I'm going to put in there, where did I go? 4 pi over 3. Cosine of 2 pi over 3 would be -1/2. So I end up with -3. So that's interesting. At 4 pi over 3, it goes back 1, 2, 3. Most intriguing. All right. This is a weird looking dude. That's why I picked it. Let's see. What about 3 pi over 2? I can do 3 pi over 2 because if I cut that in half, I'll get 3 pi over 4. Cosine of 3 pi over 4 is -rad2 over 2. I get -3. We can do it, Jeff. Can you do it, Jeff? -3 rad2, which will be negative this, right? -4.2. So I'm going to go back. So at 3 pi over 2, I'm going to face 3 pi over 2, and I'm going to go back 1, 2, 3, 4.2. So right there, neato. And then, I mean, I'm just going to keep going. So if you just keep going, just like I have been, this will end up looking like this. Let me see if I could do this well enough. Oh, Jeff, you can't do it well enough, can you? Yeah, you can do it. Come on, buddy. Come on, buddy. You can do it. You're getting there. Yay. And then since you know it's symmetric around the x-axis, because I would either just tell you that or I would give you the test and say verify, you just have to copy the stuff down. So you can kind of like do the points down here, the reflection points. Are you guys with me? And then you got it. So it's kind of a funky looking dude. Is that helpful? I mean, that's basically how you attack any polar thing I give you. I will help you with the symmetry because I'm not going to make you memorize that because I don't actually have them memorized too well, to be honest. So I might give you some help there. And what that does, if you know it's symmetric, you have a smaller table that you have to put together because you can just start repeating points after a certain amount. Yeah, so I mean, if I did this carefully, that's a pi over 3 and it's at 3. So this pi over 3, it'll be at 3. See, I'm doing this mirror image point here. Mirror image point there. Mirror image point there. Mirror image point 1, 2, 3, 4.2 there. So it's going to come. Oh shit, Jeff. So I've also, so that's kind of like the inner little circle dude there. Oh shit, you almost got there, Jeff. And then you got this stuff sort of like living on the outside. Living on the outside. Bum, bum, bum. That's horrible. That's horrible. But it's not bad, to be honest. It's not terrible. I guess terrible is worse than horrible. Same swirly thing. What do you mean not just a circle? Yeah, so it's going to look exactly like this, reflected. Right, so somebody stepped in my pond. That's my reflection isn't perfect. Somebody threw something in my lake here. So that's why this is all freaky. All right, you guys don't like that joke. It's okay. All right, let me see. Did I miss anything else that somebody's asked me? So that's a polar example. We could do another one if you want. Or let's see, does anyone have, who was somebody, what problems, does somebody have any problems in the practice final they want to ask me about that I might not have gone over in the video? Everybody remembers there's a solution video for the practice final that apparently passed Jeff. Didn't really do all of them because he was a lazy guy. Not like me, I'm much different. Are we allowed to use a calculator? Of course you are. You're still gonna have to show your work though. Yeah, and you need to understand what show your work means. So for example, when I did this here, you don't have to know how to get that to be 4.2 in your head. You can put that in your calculator, that's fine. You just have to show me, some work. That's all. But you can use the calculator to get like the last step to make it a decimal. That's fine. Okay. Okay. Yeah. All right. I know somebody had asked me about problems I hadn't done on the video. Here, do you want to just, okay. If nobody has any questions, it's going to be a very unproductive meeting we're having. So pretty cool with these first three here. All right, let's see if I get any. All right. What about this one? Somebody was, no, I wasn't, that's right. Somebody was asking about number 4 in the midterm, not this, but so pretty cool with all of this here. I really seem to like this kind of problem where I give you a function, a graph, and you have to do several things with it. This is a question from yesterday. Can we review converting equations from polar to rectangular like the ones from quiz 10? Oh, yeah. Sure. Somebody's got a question about converting polar to, I don't think I have, oh, here we go. Here, look. All right, this is the easier direction. We'll do one the other direction. But let's look at number 15. Who remembers the conversions between polar and rectangular? What is x equal to? Between polar and rectangular, what is x equal to? R cosine theta. Yeah. And then of course, y is going to be our sine theta. And that's another reason why SOHCAHTOA can suck it, because if you know that x likes cosine, then you know x is r cosine theta. It makes sense. Yay, SOHCAHTOA. Go SOHCAHTOA. All right. Let's see, what else do I need here? What is r squared? Converting from rectangular to polar and vice versa. What is r squared?
X squared plus y squared.
Yeah, x squared plus y squared. So you guys have to know all these. These aren't too crazy. All right, so now look at this. It should kind of scream at you what I need to do to start working on this. Unfortunately, some of you guys see sine and you just put a y there. That's not what y is. What is this missing to become y?
R.
R. And what is this missing to kind of go along with this guy?
R.
R. And what is this missing to become something really, really? R. So of course I'm going to multiply both sides by R, because then it's going to fall into everywhere I need it, right? So if you see a cosine sitting there and I'm asking you to convert to rectangular, you want to somehow get an R in front of that cosine, because then it's just x, right? Okay, so if I multiply both sides by R, I'll get here. And of course, 0 stays 0. So r squared is x squared plus y squared. For r sine theta, of course, that was y. R cosine theta squared is just x squared. Now, the really nice thing about this problem is Jeff has just like put a lot together. So we changed it to rectangular. Can you identify what conic section this is? Well, there's one little thing I need to do. Is there any like terms in this thing?
Plenty.
Just those two. So I got 4x squared plus y squared plus 4y equals 0. Can somebody tell me, is that a circle?
No,
Why not?
because the coefficient is different.
Good. So it's not the same in the x and the y direction. So that, and it's not a minus here, right? If it was a minus here, what would it be?
Hyperbola.
Hyperbola. Careful. Yeah. Plus contains, minus is what it goes to infinity, right? So that's a plus. It's not a circle, so of course it has to be the only one left. It's got to be an ellipse. So that is an ellipse. All right, I love it. I can't wait to be back on campus. Then I could actually see in your eyes that as you lose me. Right now, I can only guess that I'm losing. So how do I, so we've identified the conic section. It's an ellipse. Put it into standard form. Shit. What does that mean? Put it into standard form. What does this guy want from me? Oh, yeah, it's me.
1 equal to,
Huh?
like, I don't know how to explain.
Are all your X's in one place? Yes. Are all your Y's in one place? No. Don't you have to somehow collect those together? This guy seems like he's incomplete. It seems like we might need to complete him. That might be why I left some space here. Right? If I complete the square. Okay. You guys okay out there? I don't know. I really don't know. So the x squared stuff is cool. What do I have to add here to complete the square for y? How do you complete the square?
+4.
Yeah, so half of 4 is 2 squared is 4. So I got to add 4. So I better add 4 over here. So I get 4x squared plus y plus 2 squared equals 4. And then what's the last step to get everything correct in the right place for ellipses?
Divide by 4, both
Divide by
sides.
4. Yeah, you want this to be a 1 over there. So x squared plus y plus 2 squared over 4 equals 1. All right, let's see. So this is an ellipse, right? An ellipse, you should go, oh, thank God. An ellipse kicks ass. There's so little with ellipses, right? So how far am I going to go in the x direction? How far am I going to go left and right from? And where's the center, actually? Let's start there. Where's the center? How much has this been shifted? Has it been shifted left and right at all? No. Has it been shifted up or down at all? Yes. How much? What's going on there? Yes, down 2. All right. So the center is at 0, -2. I'm going to put a little open circle there. Don't put a point there because that's not a point on the ellipse. It's the center of the ellipse, which means it's definitely not a point on the damn ellipse. Now, from the center, good Lord, what is happening out there? Sorry, my neighbors, I don't even know if you can hear. How far am I going to go from the center in the left and right directions? In the x direction, how far do I go from the center? 1, right there, right? The number with the x is the square of how far? Oh, okay. So real quick. Let's see. Yeah. Where's the vertex for this parabola? Do you guys remember how to find that? Where's the vertex for that parabola? How much is it shifted? What are the shifts in this equation up here? Somebody's asked me how I got the down 2. It's been shifted left or right, up or down. How's this been shifted?
Left to 3.
Left 3. Yes. How do I know it's left? Because it's in with the x. And isn't the x-axis left and right? And why is it back 3? Why is it left 3? Because the first thing I do is add 3. So all my inputs can be 3 less. So that's a beautiful thing. If it's with the variable, it does the opposite of what it looks like. That 3 is with the variable. It's adding 3. So I'm going to actually go back 3. So look here. What variable is the shift with? Isn't it with the y? Y is up and down. It's going to go down 2. Bam. Okay. I like it. So that's nice. So from the circle, so far as from the center, I'm going to go up and down 2. So I'm going to go down 2, up 2. And how far am I going to go left and right? I think somebody already told me. I'm going to go left 1, right 1. Oh, yeah. Why did I? All right, listen. I kind of skipped over something. Like, how did I get 2 on that? How did I know to go up and down 2? I kind of got so into the 2s. I thought we'd already answered this. Isn't this 2 squared? And it's with the y. So that's how I know it's up and down that much. Okay, good. This one is 1 squared and it's with the x. That's why I know it's left or right 1. So there's my ellipse. Whee! So an ellipse, x squared over a squared plus y squared over b squared equals 1. A is how much I go left and right. B is how much I go up and down. And this would be centered at the origin. So anything that's in with the x or the y just moves the center in whatever direction. Okay.
Do you have to find a foci for this?
Find the what now? Oh, the foci, if I ask for it, sure. Well, does anybody remember ellipse is a plus? So the focus equation will have a minus. Right? So it'll be c squared equals 4. You know, it'll be this guy squared minus, I mean this guy minus that guy. So c is rad 3 plus or minus. Yeah. Okay. I'm not overly excessively interested in the foci, but I'm just glad you know they exist.
Because it says important points. It's not.
Yeah, I'm with you. Yeah. Yeah. But I'll be more explicit on the final.
Okay.
Okay.
Thank you.
Sure. Let's see. So that sort of morphed away from the original question. The original question was just translating from polar to rectangular and vice versa. So what if I had, let's see. Erase this guy. Today would be good. Today would be great. Go away. So what if I had a rectangular equation? So let's see. Y equals y over x plus x squared plus y squared. All right. And I want to translate that into polar. Do I need to do anything before changing it into polar form? Should I multiply everybody by x? Can you identify anything there that's already ready to translate into polar?
Yes.
Yeah, what's x squared plus y squared?
R squared.
R squared. What's y over x? Who remembers that?
Sine over cosine.
Tan theta.
Tangent, I like it. And of course, y is just good old r sine theta. I like it. So this way, I mean, if I start off with rectangular, that's not that bad. You just have to remember the conversion formulas, right? You just got to remember these guys. Not too evil, I hope. All right, let's see. Oh yeah, that's why I was trying to remember why I jumped down there. All right, so let's come back up here. So any questions on number 4? I want you guys to understand, you could ask anything you want to, because what's the final going to cover? Everything. Do you have a question from chapter 1 that bugged you? Bring it up. Do you have corrections you're working on? You have no idea what the hell to do with them? Ask me now. Did you try the practice final? You had no idea what I meant on number 7? Do it. Did you watch the solution video and you still don't understand something? Ask me now, right? I have brought nothing to this tonight or tomorrow. Holy shit, we get to do this tomorrow. So to get something out of this, to make this productive, I'm going to need you guys to ask questions. You can ask, I completely forgot how to do trig identities. Can you kind of teach me that again? And then I'll kind of work with that. I'm not going to teach you it again, but I'm going to work with that. It'll be something we can talk about. You can be very specific, very vague, very general. I mean, if everybody's ready for the final, we might as well just take a couple days off and, I somehow doubt that though. Not that I doubt your abilities, but pre-calculus final is not the easiest thing in the world. Even with all that, nothing. Okay, we'll keep trying to do this. Okay, so there's this kind of problem. This shouldn't be too evil, I hope. How do you graph the inverse? Oh, got a chat. Oh, okay. Somebody's got a question. Okay, I'll come back. How do you graph the inverse real quick? Anybody remember? How do you find the inverse? If I give you a function, how do you find the inverse? What do you have to do?
Change x and y.
Change x and y. So how do you graph? You take the points and you
Change x and y.
change all that shit. You gotta love that. That's the idea of an inverse, represented every way you can represent an inverse, right? Graphically, speak about it, algebraically. I mean, it's crazy. All right, so I'm collecting some chat questions. Okay, so let me go by one. Eliminating the parameter. Okay. Do you have a specific question about it? The eliminating the parameter question? I don't think I did. I put, oh yeah, that would be in this down here. So what if I had to, oh yeah, this would be very challenging. This one right here. I don't think I would give you this one to eliminate the parameter. This is not easy. Let me see. There's a chat. Oh, okay. These things happen. All right. Person that asked about the parameter. Are you thinking about a specific problem or just, I can give you a couple of general situations. Is that what you want?
For example, like on the quiz, that eliminating the parameter one.
Oh yeah. All right. Hold on. Let me see what that would look like again. Okay, where are you? Quiz. All right, quiz 11. Oh my God. Every kid in the neighborhood is out in my yard right now. All right. All right, here we go. Was this one weird? Is that what it was? Oh, this one was so cool. All right, sorry. All right, I remember this one now. I didn't even see it in it. All right, here we go. I might be the only person that feels this way about this problem. That's okay. All right, why do you show up in the wrong screen? All right, so the one on, yeah, so okay, so let me make another problem sort of like that because I seem to like this kind of problem. So what if I had these parametric equations here? You could do it, Jeff. How about, sure. Yeah, let's do that. I like that. You can do it, Jeff.
Professor, if you're writing, we can't see anything.
Oh, I'm sorry. It stopped sharing for some reason. There we go. Can you see this?
Yes.
Okay. I love it if I ask that question, you're like, I see something. I don't know if it's this you're talking about. So I just wrote a problem down, parametric equations. All right. And I'm going to ask you, so this should look a little bit like the problem you had on the quiz. Yeah, it looks exactly like it. Okay. So what the shit does this guy expect from us? Oh, wait, that's me again. What is the, can you give me, all right, the one on the quiz is actually easier, to be honest. But can somebody remember that? You better remember this. What's cosine of 2t? What's one way I can rewrite cosine of 2t? What's one way I could rewrite that?
1 minus 2 sine square t.
Yes. And in fact, that's the one I want to use here. right? Because the other way to do it is cosine squared t minus sine squared t, or 2 cosine squared t minus 1. And this one is the greatest way to do it because I can solve this for sine. Do you guys see that? So I can solve this for sine. And then I could just plug it. So this is going to be twice 1 minus 2 sine squared t. So then I have x equals, is everybody cool? I'm going to take this equation. X equals twice 1 minus 2 times sine t squared. Do you guys see what I'm saying? That one pretty much exactly relates to the one you had on the quiz. So it should be a little easier to do your quiz correction now. Although, let me see if there was a little twist to that one. Was there? No, there really wasn't. Oh, there sort of was. There sort of was. What if I, how do I want to say this? Can somebody tell me what would cosine of t be? Could you figure out what cosine of t would be? Is there a way to figure that out? If I know this, if I know sine t is y plus 1 over 3, can I figure out what cosine of t is?
We got 9 minus y plus 1 squared.
All right, let's all catch up to what you're saying. So based on this, can't I draw a triangle based on angle t, right? Now, of course, as I think you might have used an identity, right, Rio? I kind of like this visual way about it. I really need you guys with me. So a lot of what we're doing is going back to the basics. Sine is the ratio of what to what side to what side. I think I saw Charles mouth the answer. So it's going to be the y side over the hypotenuse. And if I want to know what cosine is, I need the x side. I need this side. So that would be the square root of 9, 3 squared, minus y plus 1 squared. So why am I telling you that? Because that is another piece you would need for the quiz correction. Okay, no reaction. Let's see. Let me catch up, I think. Problem similar to 10b. So I guess you mean 10b.
Final.
Practice final? Okay. Let me see. Where'd you put that at, Jeff? Here it is. Oh, this one. So, I mean, all right. So when you say similar to, did you understand? I guess you didn't understand this one, but you want a different one because you've already seen me explain this one. Is that what that is?
Yes.
Okay. The approach is the same though. It's kind of like if you all right. Let me think. So what about log base 7 of x plus 1 minus 2 log base 7 of 3x plus 3. What else you got, Jeff? You got more? Yeah, sure. Plus log base 7 of 9. Yeah. I like that. That last piece is for any Star Trek Voyager fans. Log base 7 of 9. 7 of 9? No, okay. So what the hell do I do here? What's one thing I have to do before I can just attacking this with logarithmic properties? What does that mean, Jeff? Well, what's like log A plus log B? Who remembers? What's log A plus log B? How can I rewrite that?
Log AB.
Log AB. When do you add powers? When the things are being multiplied, right? So logarithmic properties are the same as exponential properties because logarithms are exponents. So what's the very first thing I kind of before I can start putting these together, I don't have log minus log. I have log minus 2 times log. God damn, 2. How do I get that 2 out of there? Do I just erase it and hope that I missed that you just erased it? How do I get that 2 out of there? What's the property of logarithms that can help me get rid of that 2? Get that out of the way. Where can I put that 2? I'll tell you where to put the 2, Jeff. Come on now.
Move it to the end.
Remember that? Logarithms are the only things that have a property where they can bring a power down. So of course the power can go back up if it wants to. Math goes both ways, right? Be jealous. So now I've got minus log base 7 of 3x plus 3 squared plus log base 7 of 9. Okay. So what's that mean when I subtract 2 logs? How can I rewrite that? Log base 7 of, what does it mean if I'm going to subtract 2 logs?
Divide.
Yeah. Adding them means the log of the product. So subtracting them means the log of the quotient, the log of the division. So it'll be log base 7 of x plus 1 over 3x plus 3 squared. And can we go ahead and just suck this dude in? What's going to happen? All right, that was a very strange phrase. Plus log base 7 of 9. Since I'm adding it, where should it end up? Are you guys at all with me? Since I'm adding this 9 should end up here. Multiply by, right? So I'm going to divide by this, multiply by this. Now, if you stop there, that's a problem. I don't want you to stop here because there's something you can still do. What can you do with this?
Factor.
Yes. Now somebody else tell me. What can I factor from where? Can't factor the top. The top is already factored, correct? Oh, I got a chat coming. No, not really. That doesn't really get me anywhere. I've got 3x plus 3 already factored. What comes out of 3x plus 3?
3.
3. And how many times can I do that? Twice. Don't it? Isn't this this? Right? Isn't that this? Isn't that this? Yes, 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 yes. So I can take a 3 out of this, and I can take a 3 out of this. 3 times 3 is 9. The shortcut is take a 3 out, square it. Isn't that beautiful? Kind of awesome. And then and then what happens here? Well, a 9 cancels and an x plus 1 cancels. So I end up with 1 over x plus 1. Donezo. All right. All right. What got me into that one? Hopefully somebody asked a question about that. All right. Then I just kind of start doing it. Okay, yeah, that's right. Problem similar to 10b. Is that okay, Isabel? Or is that
Yes.
okay? So it's all about remembering the basic properties. Any coefficients, when I'm trying to combine logarithms, I got to get coefficients the hell out of the way. Because I know what log plus log is, but I don't know what log plus twice log. I need the 2 out of the way. And then minus means rewrite it as the log of a quotient, all that kind of stuff. And when you're done with the log shit, you got to take a second to figure out, well, can I simplify all the stuff I've crammed together now? Maybe I can reduce that. Let me see. I'm catching up to the chat. I'm sorry. I think, yeah, I'm ready for this one. Can we, an example about synthetic division and behavior roots, y-intercept? Sure. Did I not put a problem here? Oh, I did. Yeah, this one. Right? So, all right. You guys remember synthetic division? What kind of, can somebody give me a good number to try to synthetically divide this by? Remember making a list of possible roots? what would the list of possible roots here be? Plus or minus
139.
139. And it's nice because there's no number out front. Remember, that would be on the bottom, make a bunch of fractions. Is this coming back? So of course, I'm going to try to divide by 1, 3, or 9. You could think about analyzing the changes in sign, but it doesn't look like that's going to help us, right? To see if how many positive and negative roots there are. This is not a big list, so who cares? We might as well just start trying these out. So take a minute and try, if you haven't done this problem yet. Somebody divide by 1, somebody divide by 3, somebody divide by 9. Let's see if we can get something to work. It might be negative answers. I don't know. I don't remember. It looks like there's going to be 2 negative roots and 1 positive root. Has anybody divided by 1 yet? Has anybody tried 1?
I tried 1.
Does it work?
Yes.
Yes. Okay. So 1 times 1 is 1. 5 plus 1 is 6. 6 times 1 is 6. 3 plus 6 is 9. 9 times 1 is 9. Negative 9 plus 9 is 0. Yay! So what does that mean? How have I factored it so far? What does this relate to? The 1 in the penalty box. What does that write as a factor here? What does 1 relate to as a factor?
Minus 1.
X minus 1. And of course, what's this? What's left?
X squared plus 6x plus 9.
Kick ass. And that's easy to factor. I'm just going to do it. Bam. All right. End behavior of this function. What's the end behavior of this function? And the quickest way to answer this is a little picture, right? So what's the end behavior going to be? What's the degree?
Cube.
Cubed. So it's going to be cubish. It's positive cubish, right? So it's going to go like x cubed. So that's the end behavior there. It's going to start low, and then it's going to do weird shit in the middle, and then it's going to go high. I leave the middle blank because I don't know. It's going to be all curvy in the middle probably, right? What are the roots? It's easy to tell that we said we did this. What are the roots? I don't know why I wrote 3 of those. Anybody? I'll start us off. 1, 0. 1, 0 is a root because 1 makes it 0. So what's another root? Remember, what's root? What is root another name for? Cheer. No, not root your team on. What's root another name for? Root is another name for x-intercept. So thank you, whoever said -3. I like it. What's the multiplicity of this root? So now we're going to look at this. Don't worry, we're going to come back to this guy. What's the multiplicity of 1, 0? 1. So is it going to go through or turn? Through.
Through.
And I love the people that write at least as bad as I do. Your through looks like the word turn. So maybe I should write, like somebody did, the whole word. You write through and it looks like through, and it could be turn. Oh,
That's why I
God.
use bounce instead of
Bounce.
turn.
I like it. Yeah. So -3, of course, is going to go bounce or turn because it's like a parabola. It's squared. It's an even power. Okay, I like it. Is this coming back to you guys at all? You guys remember this is a 6 credit class, right? If you're like, wow, this is a lot. Well, it's a 6 credit class. That's going to have a lot of shit in it. All right. What's the y-intercept? Really easy. I don't have to do any work.
minus or 0 minus 9.
Good, yeah. I just go back to its pre-factored form, and it's the poor little number all by himself. It's the only one that doesn't die when x becomes 0. Right. This is your friend down the street with a bunker. He's the only one gonna be left alive. Okay. That's not a don't start buying a bunch of prepping things. All right. Let me see. So we got 1, 0, negative 3, 0. That's my intercepts. My y-intercept is 0, negative 9. Do you see any other points I might want to find out to help me out? Because I don't want to do this scale until I kind of know where things are. So let's see what I got. I'm going to start down here. I'm going to come up here. I'm going to turn at negative 3. I'm going to go through negative 9 over here somewhere, and then I'm going to go through. So I actually could sort of get away without doing another point, but it would be good to know, like, where is it at negative 1, for example, right? So let's see, what is f of negative 1? It would be negative 1 cubed. 5 times negative 1 squared is 5, minus 3 minus 9, and that's going to be, oh God, is that negative 8? Yeah. All right, so that's not too bad. 2, 4, 6, 8, 10. So negative 8, negative 1, negative 8, and then it goes through 0, negative 9. Is everybody with me? I'm just plotting points. I found one more point just to kind of see where things were. And then you just sort of, I'm going to turn. So I start down here. See that? I start down there. I turn. That's good because then I got to go through this shit down here, right? Oh boy, this is pretty bad, but oh well. I'm just showing you how bad yours can be and it'll be fine. Okay, there we go. Make your points real big. Everything's fine. All right. And that's kind of like what you would expect a cubic to look like. Little Loch Ness Monster looking dude, right? Loch Ness Monster. All right. Is that all right? Charles. This point doesn't matter if it's not all right, Jeff. I understand. Let me see. Did I miss anything in chat as far as questions go? Oh, can we? Oh, this is this one. Was that okay? Person that asked about synthetic division. I guess so. You were participating. Okay. And again, so all right, now guys, let me give you some all right, let me give you some advice. The way I would do this is if there was anything on the practice final that you completely forgot about, I don't know if you think I had too many handouts or not enough handouts, but you're almost guaranteed there's a handout related to something you're not always sure of. And where are the handouts? Up on frickin' Canvas. So you could go get that. And I tried this semester to be really good about labeling my lecture videos with the topics. So you can even search, I don't even know, there might be a video from like 5 years ago that I did when I last taught pre-calculus. So if you search my YouTube and you just type in like, I don't freaking know, end behavior or something, you never know what's going to pop up. Yeah. Or you just kind of look in the right time frame and then look at the description and you can see where we talked about these things. So that's what I would do if I were you. I'd look at the practice final, identify what I'm the least comfortable with, and then go see if I can find a handout, worksheet, video related to those things, or bring them tomorrow and ask to do some example problems. Does anyone else have anything they want to look at right now? What does the W thing mean? You mean the curvy W? The curvy, I'm sorry. The curvy W like this? Yeah? Yes, okay. Who remembers what that means? Not even its name necessarily, just what does it represent?
It's one of the Greek angle, or it's an angle, but it's one of the Greek
Okay,
alphabet.
it could be an angle, but it's not very often used as an angle.
Velocity.
Yes, what kind of velocity? Obviously, yeah, angular velocity. I like it. So this is theta over time, right? So like change in theta over change in time, how quickly your angle is changing. So the Earth rotates 15 degrees per hour. That's how quickly the Earth rotates. Think about it. Multiply 15 by 24. What do you get?
360.
Yeah, which makes sense. It rotates fully in a day, correct? So 15 degrees per hour is exactly what you would expect a spinning ball to go, right? Unless you're a flat earther, in which case, don't tell me. Keep that to yourself. That'll make me weep openly at night into my pillow. Okay. Is that okay? I don't know where that, did I have a question on here about that? I can't remember if I really did any.
No, you didn't. But you may have had a question at some point, but no, I was looking over the periods for like sine cosine graphs, and like sine squiggly w or curvy w times theta is supposed to be equal to t equals 2 pi over the w. So I wanted to make sure that
Oh, sounds like, is that in our book? But that sounds more like the K. And you figure out the new period by doing 2 pi divided by K.
that's
So there could have been somebody just decided to use a different variable. They decided to use this variable, which is weird. Well, it's not really weird, to be honest. I really want this to make sense. Okay, so let me take a step back. This makes a lot of sense because if this is change in angle per time, what do you get when you do change in angle per time times time? Don't you get angle, right? So that's sine of an angle. That makes sense. Yeah. So yeah, that's a possibility. If you're talking about angular motion, this could be one of the formulas for the motion because it does capture the angular velocity. Yeah. So I don't know. Yeah. I guess that could have been in an example or something.
I think it was like when you're doing the whole spinny playground thing.
Oh
we were
yeah.
talking-
Okay. Okay. All right. So that's my suggestion to you. I don't know if anybody's tried to do that. I would suggest that homework is kind of key, but at this point, if there's entire sections of homework you haven't done, I'm trying to figure out what's the most important thing for you to do. Looking over the practice final and identifying what looks weird is a good start, right? And saying, I really don't remember anything about that. I sort of remember that. So you can prioritize what to look at, correct? As far as your grade goes, any corrections to quizzes, any corrections to midterm, any corrections to homework, any homework you haven't done yet, that would be in that order. Midterm corrections, quiz corrections, homework you haven't done yet, homework corrections. That's the order of importance in terms of affecting your grade. And the nice thing is any of that you do should help you study since the final's cumulative. Isn't that crazy? So you're raising your grade and studying at the same time. Oh my God, it's almost like Jeff did that on purpose. Cool. Let me think.
Almost seems like the point of homework and quizzes in the first place.
Holy shit. Holy shit, Batman. So, and that's one reason why I do corrections is because when I was a student, I got my test or my quiz back and all I did was kind of like go, shit, if I didn't do that and I didn't, shit. And then I just forgot about it. And I'm like, man, if only I would have had some motivation to try to redo, and it's not, I'm not saying I never did because I was a semi-good student, but if only there was some motivation for me to do it, because I mean, we only have so much time. So if there's motivation for me to do something, I'm gonna have more reason to do it. And hopefully, anyway, all right, it's just, that's my thought process. Anybody else not sure how to study for this, or are you guys trust in your method, or do you need some more advice about how to do that? Okay, all right. So let's do this. In between now and tomorrow, I need everybody to identify at least one question, specific or general or somewhere in between, right? It could be something like, all right, cosine of 315 degrees. I don't understand that. Or it could be, what the hell is trigonometry, right? So somewhere, anywhere on that spectrum of specificity, right? So anything. So just do that for me. So that's the whole purpose of these last 2 days, is to get ready for the final. And if you guys don't come with much, I'm not sure where to go, because it's all about me filling in the gaps you have. And if I don't know what those are, I can't help you. All right. It looks like questions have died down for tonight. So I was going to go ahead and stop class now. Just pick it back up tomorrow. Oh, did I say this before anybody goes? Did you guys notice I don't think I said this. I added some stuff into Canvas. Let me see. You do it, Jeff. Can you do it, Jeff? Oh, right here. So right here. This is sort of my schedule for next week. So I'm going to have general office hours on next Tuesday. And then our final exam is that Tuesday evening. So I'm going to have office hours just for you guys. And then our final starts at 6:05, which is nice, because if you come at the normal time, you're early. That's good. So right now, if you click this link here, there's no Zoom link yet. I just haven't created it yet. So I'm going to put that in there. That'll be where you go. And I'll make an announcement too, since some of you guys might be used to going to announcements. I'll do both. But this is where those are going to be for next week. What's happening Monday? Did I already say this earlier? I can't remember.
Memorial Day.
Yeah, don't come on Monday. Monday's a holiday. Yeah, in fact, this week is the end of all classes, right? At the end of this week, no more normal class. Next week is all finals, and everybody's final is at a predetermined 2-hour block. So make sure you know which 2-hour block for which class. So hopefully your professor has been explanatory about that. And the final is going to be just like the midterm. Cameras on, set amount of time. Everybody starts at the same time. Everybody ends at the same time. Get to class on time, because I am going to lock the class after about 10 minutes. Because after about 10 minutes, if somebody comes into class, maybe they've been working on the final already for who knows however many minutes while they were off camera. No, I'm not going to do that shit. So if you're not on time, you better write me an email explaining what the hell's going on and how you're desperately trying to get things working. Now, don't get me wrong. If you have technological problems, I will work with you, because I understand that happening, right? But do everything you can to log in early so that you know there's no problems. Okay. But
Professor,
sorry?
what about if the Zoom meeting kick me out, because my internet sometimes it's come bad and they kick me out?
Yeah, just get back as soon as you can. And if you're having like a lot of trouble getting back in, shoot me an email so I know what's going on. And then if it becomes an extended period of time, we're going to have to figure something out. Does that make sense?
Oh, okay.
Yeah. So I will work with anybody with technological issues. At the same time, to maintain the integrity of the test, I can only stretch that so much. But then if you, in the worst case scenario, you could retake the final another day or something, whatever's going to make it work. Yeah. So, I mean, we'll just have to deal with those issues as they come. And depending on how big the problem is, the answer is going to have to be big. So we'll see. All right. Anything else for today, or do you guys want to just go and get ready for tomorrow? Okay. All right, guys. You're all free to go. I'll see y'all tomorrow. You're welcome.
Have a good night.
Ready with questions?
Hi, Professor.
Yes.
Could I ask you specific questions about from quiz 11?
Sure.
I still haven't done the corrections for it yet, so.
All right.
Questions.